After talking about how clouds form, now we need to speak about how rain forms. What we mentioned maybe once before, but I'll mention it again, is that we have particles in the atmosphere, that every single drop of every cloud in the sky has to form on a particle we call a condensation nuclei. These are microscopic particles in the atmosphere. There may be dust, there may be salt from the oceans, or sulfates or from plants. They're all around us. There may be thousands in every centimeter cubed around us here in the room. And these are the nuclei that droplets form on. And they may be, as you can see here, 0.0002 millimeters. We can't see them. But this is what the cloud droplets form on. Cloud droplets are maybe 0.02 millimeters. And then the cloud droplet has to actually attach with maybe another million droplets in the cloud to form a raindrop of 2 millimeters, which is heavy enough to fall to the ground. So it's not a trivial issue to go from a cloud droplet to a rain droplet. In fact, most clouds in the atmosphere will simply evaporate and disappear. Most of them don't produce rainfall. So rainfall is actually the exception. And that's important for our drinking water and for our agriculture, obviously. So how does rain actually form? So there are two different processes. One occurs in clouds which have only water droplets. We call these warm clouds because they don't have any ice. And then we also have cold clouds, which are most of the clouds actually, especially in mid-latitudes, in Israel, in Europe, which produce rain, which do have ice. But in the tropics, we have warm clouds, which are basically made up of droplets of different sizes. And here we have a process called collision coalescence, where big droplets will collide with smaller droplets and stick to them. They will coalesce, they will grow into a larger mass. As the droplets get larger and larger, they'll fall faster through the cloud, collecting more and more of the little droplets, and eventually they'll get to the size of 1-2 millimeters and will fall as rain. So the warm rain process is quite common in the tropics, where we have very warm temperatures, and it doesn't need ice, just simply by the collision of droplets together. And if all the droplets are the same size, we won't have any rain because they all fall at the same speed. So we have to have a distribution of droplets. We have some big ones, some small ones, and then the big ones fall through the others and we'll collect them, and that's how we get to rain in clouds which are warm. In cold clouds, first of all, even ice crystals don't form out of nothing. They also have to form on nuclei. We call these ice nuclei. So we have cloud condensation nuclei, we have ice nuclei. Ice nuclei can be also dust, soot, bacteria. Once we have the ice and the droplets in the cold clouds, there's often a mix between them. We have both droplets and ice together. Turns out the snowflakes and the ice crystals actually steal the water molecules from the droplets and grow much faster, and the droplets actually evaporate and donate their water molecules to the ice. These grow into big ice snowflakes or ice crystals, maybe even small hail pellets, and eventually fall through the cloud and can also collect water as it's falling down to the ground. This process of the ice crystals and the snow growing at the expense of the water droplets we call the Bergeron process. And this is only when we have ice and water droplets together in the same place in the cloud. Well, how can that be? How can we have ice and water together, you may ask? Well, there is a strange phenomenon in clouds which we call supercooled water. This is actually water that occurs below 0 degrees. We all think that the water freezes at 0, but when you have very clean environment, very clean water, it actually can go quite far below 0 before it freezes. And you can actually see in some of the supplemental material for the course some links of videos where you can see this in doing experiments where you can actually put water in your freezer, and if it goes down -5, -6 degrees, you can carefully take it out while it's still liquid, and you can give it a flick and it will turn into ice immediately. So what happens also when ice is falling through the cloud, if it touches or collides with the supercooled droplets, they'll freeze immediately. As you can see in this ice crystal, the snowflake with the little dots on it, the little circles are the minute cloud droplets which freeze onto it, giving it extra mass, making it heavier, and it'll eventually keep on falling to the ground. On the bottom right image, you can see a similar process which we call riming is when we have actually liquid water which comes down and touches areas which are below zero and freezes immediately. So you can see the car which is completely covered in ice here because the rain actually came down in a warm atmosphere, or the rain was super cool droplets. They touched the car and froze immediately, covering this car with ice. A process which happens also in the clouds, this riming process where the snowflakes, the ice crystals collect the super cool droplets. Now, in clouds, we also have this riming process where we have the ice collecting water, also gives us hail, which can produce hailstorms, can be dangerous obviously for property, for our cars, for people, but also for agriculture. And in storms, which are very intense, we can have these hailstones like a roller coaster ride. They can come down to where we have the super cool droplets or even liquid water above 0 degrees, collect the water which freezes on the ice. They can be taken back up high into the cloud where it's really cold, below zero. They'll freeze again, comes down, collects more water, and you build these layers like an onion. You can build these layers and get really big ice hailstones. And often you can see, like in the bottom image, you can have different colored ice. You can have the clear ice, you can have the milky ice, and this is related to how fast the ice will freeze, or the water will freeze when it touches the ice. When it's very slow, the freezing, the air bubbles can leave the ice, and so it's clear ice. And when it freezes very quickly, it traps in the air bubbles, and we have the milky ice. And here you can see also how many of these raindrops have stuck, have frozen on these hailstones. You can see these little balls on the outside. These are the riming process where you have super cool droplets, rain droplets, which are colliding with ice or small hail, and they build these big hailstones on the way down. So the process of producing rainfall is actually quite a long process. We have to start, first of all, with moisture in the air, and we have to have these nuclei for the droplets to form. We need this to ascend. We need the air to rise, so we need it to be either heating by the sun or some convergence of air being pushed up a mountain maybe. So we need to take the moist air with the particles, and it has to rise up and cool. It has to rise up far enough for us to have saturation, for the droplets to condense to form a cloud. And then we have to have, in addition to the condensation, we have to have ice forming or collisions with other particles so that it will grow. We said we needed 1 million cloud droplets to form one rain droplet. So all of these processes have to happen fairly fast to produce a big raindrop or ice crystal, and then it to fall as precipitation. The weakest link is actually this jump from the cloud droplets or the small crystals to the rain, to go from this one cloud droplet to putting 1 million of them together to form one rain droplet. This is the weakest link. We have to pass this step in the ladder before we'll have rainfall at the surface.